going from B to A is positive. So the average velocity will be 0. Alright, let's do another problem. A plot of position versus time of a moving object is shown in the diagram here. I hope you can see all that diagram. What are the average velocities for the segments AB, BC, CD, DE, EF and FG? What is the instantaneous velocity at the point D? Well, you know that if the position against time is a straight line, the average velocity will be the slope of that graph. So the average velocity for the segment AB is the slope of the line AB. Average velocity is the slope of the position graph against time. And therefore, for segment AB, what is the slope? Can you tell me what is the slope of this line AB? AB will be delta x divided by delta t. You notice that delta x is the vertical line, delta t is the horizontal line. What is that delta x? Delta x is 2 minus 0, that is 2, and delta t is 1. If you notice, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the x position goes 0, 1, 2, 3, 4, 5, 6, 7. Alright, so delta x is 2 meters, delta t is 1 second. The average velocity for that segment AB will be 2 meters per second. How about segment BC? Segment BC is horizontal. Tell me, what is the slope of a horizontal line? It is 0. What does that mean? It means during this time that object is at rest. In fact, if that object is a person, he got into McDonald's for a coffee during that time, he is resting. There is no velocity, there is no change in position during that time. Therefore, the average velocity is 0. There you are. How about for segment CD? Alright, what is delta x? Delta x will be 4 minus 2, that is 2 meters. Delta t is, you see that, this is 3.5 minus 2, that is 1.5. 2 meters, that is delta x. Delta t is 1.5 second. That will be 1.3 meters per second is the average velocity for that segment CD. Alright, how about the segment DE? Well, I want you to look here carefully. What is delta x? Remember, delta x is final position minus the initial position. What is the final position here? The final position is negative 1.5. What is the initial position? 4 meters. So that will be, final position is negative 1.5 minus the initial position is 4. Negative 1.5 minus 4 is the change in position delta x. Delta t is 6.5, this is 6 seconds, this is 6.5 minus 3.5, alright, and that will be negative 5.5 meter divided by 3 seconds. That is negative 1.83 meter per second. Notice here that the velocity is negative during that time. How about the segment EF? Again, EF is horizontal. The slope of a horizontal line is 0. The average velocity there is 0. Alright, how about FG? For the segment FG, can you tell me what is the change in position? The final position is 0. The initial position is negative 1.5. Therefore, what is delta x? It will be 0 minus negative 1.5. Is that right? Final position minus the initial position. That is 0 minus negative 1.5, which will be 1.5 meter. And the time interval is 1.5. And that is 1 meter per second is the average velocity during that time. Well, this kind of simple problems you must be very familiar with. Alright? What is the instantaneous velocity at the point D? You can see at the point D, the position function is not smooth. That is where the object reaches a point and maybe turns back. That means the velocity there is not defined. The derivative at D is not defined because at D, the slope of the tangent line can be that way or that way. That means the derivative at that point is not defined. So, velocity at D is not defined. On the other hand, if at D the curve is smooth, the velocity there will be 0 because the slope of the tangent line there will be 0. Alright, so we can now say the velocity at D is not defined. Let's now look at another problem. Alright, read this problem and see what information we have. The position of a certain particle depends on time according to x of t equal to 1 meter per second squared t squared minus 5 meter per second t plus 1 meter. Find the displacement and the average velocity during the time interval 3 seconds less than or equal to t less than or equal to 4. Alright, let's do that part. What does that mean? Find the average velocity during the time interval from 3 seconds to 4 seconds. What is the time interval there? The time interval is just 1 second. Alright, what we need to do is we need to know the position. Now, what is the value of x at 3 seconds? Then what is the value of x at 4 seconds so that we can find the change in position during that time interval. So if x of t equal to 1 meter per second squared t squared minus 5 meter per second t plus 1 meter, then x of 4, what does x of 4 means? The position at time is 4 seconds. What all we need to do is replace your t by 4. And what does that give you? It will give you a negative 3 meter. That means at t equal to 4 seconds, the object is, the particle is at negative 3 meter. Similarly, let's find the position at x equal to 3, at t equal to 3 seconds. X of 3, replace t in this equation by 3. And what is that? I want you to do this calculation on your own. Now, check whether you can get negative 5 meter there. Alright, in that case, what is the change in position? At t equal to 3 seconds, the particle is at negative 5 meter. At t equal to 4 seconds, the particle is at negative 3 meter. What is the change in position? Tell me, is the change in position positive or negative? What do you think? Alright, let's do that. Displacement is x of 4 minus x of 3. Final position minus initial position. That is negative 3 minus negative 5, that is 2 meter. So the object moved from x equal to negative 5 to x equal to negative 3 in the positive x direction. That is the displacement. And this displacement happened during what time interval? The time interval is 4 seconds minus 3 seconds. So average velocity is x of 4 minus x of 3. That is the displacement, delta x, divided by delta t. That will be 2 meter divided by 1 second. That is 2 meter per second. That is the average velocity during that interval. Okay. How about the second part? Find the instantaneous velocity at any given time. Well, instantaneous velocity is the derivative of the position function. Can you find the derivative of this function? Dx over dt will be, look at this, derivative of t squared will be 2t. 2t times 1 meter per second squared minus 5 meter per second. The derivative of t is 1. Alright, let's do that. The instantaneous velocity is the derivative of the position function. V instantaneous is dx over dt. That will be 2t minus 5. That means at any given instant, you can find now the instantaneous velocity. Now, instantaneous velocity is 2t minus 5. What is the velocity at 3 seconds? V of 3. Replace your t by 3 seconds. It will be 6 minus 5. That is 1 meter per second. What is the velocity when time t equal to 4 seconds? V of 4 is 2 times 4 minus 5. That will be 8 minus 5. That is 3 meter per second. Well, you now found the instantaneous velocities at these times. Find the average velocity between the time intervals. You see, this is the velocity at t equal to 3 seconds. This is the velocity at t equal to 4 seconds. To find the average of the two, you add the two and divide by 2. Is that right? That's how you find the average of two values. So V average is V of 4 plus V of 3 divided by 2. The average velocity is the sum of the two velocities divided by 2. And that will be 3 plus 1 over 2. That will be 2 meter per second. Now, does this agree with the average velocity we calculated in the last slide? Yes, we also got 2 meter per second there. Okay, let's... A ball